Okay, good afternoon class. At this point we're looking at the June test 2 or the paper 2 of 2022. Okay, so this is the paper you guys have written the other day. Just this is grade 12, paper 2, June 2022. Right. So the first question. So we are told in number 1.1 the scores of 8 golfers who played a single round of golf on the same golf course is shown below. The question says, determine the interquartile range of the given dot. So for the interquartile range, we know interquartile range is going to be Q3 minus Q1. Well, that's in semi-interquartile range, I will divide by 2. However, these numbers are not in ascending order. So firstly, I must get it in ascending order, so the number is 69, then 71, 70 first, 71, 71, 72, 74, 75, 78. As you can see, the dot is fairly close to each other. Okay? So the standard deviation will be very, very small. Okay? So to calculate your quartile 3, we must go take the median of the lowest set of data. So 1, 2, 3, 4, 1, 2, 3, 4. So that forms part of the bottom, that forms part of the top. So if we look at these 4 numbers in the lower set of data, so there's 2 numbers in the middle. Okay? And here we have 2 numbers. So in other words, for quartile 3, and this quartile 2, quartile 1, sorry. So quartile 3 is going to be 74 plus 75 over 2 minus 70 plus 71 over 2. Okay? So that gives us an answer of, let's get this here. So that would be 74 plus 75 over 2 minus 70 plus 71 over 2. That gives you an answer of 4. So the interquartile range is 4. The next question says calculate the mean score and the standard deviation of the data set. So the mean, so to calculate the mean, I add up all the numbers, divide by number of numbers. But since the follow-up question was, or part of that question was to calculate the standard deviation. So I'll calculate the standard deviation one time, okay, and then take it from there. Okay, we're using the setting of the calculator. So we go mode, number 3 for stack, 1 for variance. So here we're going to enter the data. So we go 67 equals 70. You don't have to put it in order. I'll just scratch over the other values. So just using these values as union in that order. But as I said, you don't have to put it in ascending order to work out the standard deviation using the calculator. Okay. So if it's AC, shift 1, 1 for variance. So if it's AC, shift 1, 4 for variance, 2 for mean. 72,5. So the mean value is 72.5. While the standard deviation, shift 1, 4 for variance, 3 for standard deviation, should be 2,78. Okay, as I indicated, the standard deviation will be fairly low. The values is a very small deviation for those values there because of the range of 4. Your interquartile range, but your range itself is fairly low as well. Okay, which is I think 9. Okay. Then in question 1.1.3, here we are told, so I'm just going to take this out here, so that I can move this up. I don't want to trying to keep the values of the data in focus. Okay. Let's pull this up here. So here we are told that how many golfers score like outside one standard deviation of the mean. So what we need to do is we need to first set up the range of the mean. So it's your mean minus your standard deviation, your mean plus your standard deviation. Okay.
Room 42 now.
So what we say is your
Grade
mean,
11 to report to room 42,
which is 72.
Patel's classroom. Thank you.
We got 72.5 minus 2,78. That gives us an answer 69,72. 69,72. And if you say your mean plus your standard deviation. If that asks two standard deviations, I would have put 2 times your standard deviation at that point. Okay, 2 times 2,78. Okay, but that wasn't the question. So that gives us an answer of 75,28. 75,28. So we must calculate how many values lies outside these values. So 69 is actually outside. 70 is inside. 71, 2, 3, 4, 5. However, 78. So therefore 2 values, or 2 players, whatever people, lies outside one standard deviation of the mean. Okay, so 2 players lies outside one standard deviation of the mean. Then in question 1.2, you are given that the interval for one standard deviation of the mean is given there. So how did we calculate the interval for the standard deviation? We said your mean minus your standard deviation and your mean plus your standard deviation. So the interval gives us 200 and 270. The question says calculate the mean, so 2 mean, that cancels if I do vertical addition, that's 470. So your mean divided by 2 would give us 470, so it's 235, 235. So the mean is 235 then. Then they ask you to work out the standard deviation. So the standard deviation, as we know that your mean minus your standard deviation is 200. So your standard deviation is going to be 235 minus 200, which gives you a standard deviation of 35. Okay? That was really easy. Number 1.3. In question 1.3 we are told. 1.3 we are told that the mean of a 5 numbers is 86. So the mean of 5 numbers is 86. 3 of the numbers are, so it's 27 plus 104 plus 54 plus these 2 numbers short. Divided by 5 gives us an answer of 86. Okay, so that's how we calculate the mean. Sum of numbers over the number of numbers. If the remaining numbers are in the ratio 1:3, so 1:3, if I leave this x, this will be of course 3x and so on. So the one number is x, the other one is 3x. So what we do now is we solve for x. So it's going to be 27 plus 104 plus 54. So there's 185. 185 plus 4x over 5 is equal to 86. So cross multiply. So 86 times 5 gives you 430. Okay. So 430 minus 185 divided by 4. So the number is 61,25. Find the other 2 numbers. So the one number is 61,25 and the other number is 3 times 61,25. It gives you an answer of 183,75. Alright? So in question 2, we are told that A, which is negative 1, 1 and negative 1, B, which is 0 and 2, and C, 6 and 4, are vertices of triangle ABC. Question 2.1.1 says, determine the length of AC, leave your answer unsimplified, third form. So to calculate AC, it's distance formula. So it's going to be x2 minus x1 squared plus y2 minus y1 squared. So that will give us the square root of 6 minus 1 squared plus 4 minus 1 squared. So that gives us the square root of 25 plus 25, which is 50, so it's 500. Okay. Let's look at the next question. In 2.1.2, the question says, determine the equation of the median. Then you are explained what the median, or you told what the median is, drawn from B. So the median is a line joining the vertex and the midpoint of the opposite side. So it's from B, so it's the midpoint there. Okay. So this line here is called the median. Okay, this is your median. So let's go. The question says, determine the equation of this line. So in pursuit of calculating that, I need the midpoint. So how do we calculate the midpoint? It's going to be the midpoint of AC, and the mid. It's going to be x1 plus x2 over 2, y1 plus y2 over 2. Okay? So that would simply give us 6 plus 1 over 2 and 4 minus 1 over 2. So it's going to be 7 over 2 and 3 over 2. 7 over 2 and 3 over 2. Alright? So now, you remember that the equation will be in the form of y is equal to mx plus c. To work out image of gradient, which is y2 minus y1 over x2 minus x1. So it's going to be 3 over 2 minus 2 over 7 over 2 minus 0. So that gives us negative half over 7 over 2. This gives you negative 1 over 7. So the equation of this graph is y is equal to negative 1 over 7x plus 2. How do I know it's plus 2? Because that is your y-intercept. However, if you didn't know that, then you can substitute b, which is 0 and 2, or 7 over 2 and 3 over 2 into the equation of y is equal to negative 1 over 7x plus c, and then you'll get c to be 2 as well. Okay, so I'm just going to write down the equation here. So y is negative 1 over 7x plus 2, because we would like to keep the diagram in focus. Okay. The next question . The next question, we are told that determine the equation of D if ABCD is a parallelogram. ABCD. So D's point will lie approximately here. Okay. So in a parallelogram, we know that opposite sides are equal in length. Okay. So if I move from B to C, I'm affecting my x value. Not so. Alright. So you can then say from 0 to 6 is 6 units. Okay. I'm moving 6 units over. Then from A to D, I must also move 6 units. Okay. So 1 plus 6 is 7. So I move from B to A, I'm affecting my Y. So 2 to minus 1 is 3.
Interruption.
So that has to also drop by
Baker
3.
and Chloe Euston.
So 4 minus 3 is of course
Baker
1.
and Chloe Euston.
So that's the coordinates of D, which is 7 and 1. Okay. Then in question 2.2, we are told that given x squared plus y squared equals 16. Okay. And you got x minus 4 squared and y plus 3 squared equals 1. Determine whether these circles touch each other, intersect, or never cross. So just something at this point you need to note is that you got two circles. Okay? And that is coordinates A and B here. That's R1, R2. If the distance between A and B is larger than the sum of the two radii, then they never touch. Okay, as you can see there. If that is the case, okay, and the circles that your A and your B, that's R1, R2, if the distance between AB is equal to the sum of the two radii, okay, then they touch each other once. And of course, if it's the other way around, if AB is less than the sum of the two radii, then they will intersect each other at 2 points. Okay, so that is what you need to note at this point, or you should know. Okay. So looking at what we have here, we have two circles. Okay. The center of the circle, the first one is 0 and 0. Let's call that coordinate A. And the radius of the circle, of course, is 4. That's R1. Then we have B here, which is 4 and minus 3. And you have a radius of 1. R2 is 1. So let's work out what's the distance of AB. So the distance of AB, we have used the distance formula already, so I don't write the formula down again. So that gives us 5. Radius 1 plus radius 2 is equal to 4 plus 1, which is 5. So since the distance of AB is equal to radius 1 plus radius 2, which is equal to 5, therefore the two circles touch each other. Okay? They touch each other. The two circles will touch each other at one point only. Alright, so it's all together. This is the case. Okay, that will be the case. They'll touch each other at one point only. Okay. There's 4 marks here in the sun, yes. Good 4 marks. Let's look at question 3. In question 3 we are told that given the circle with equation x squared minus 6x plus y squared minus 2y equals 5 with center M, diameter AB and the y-intercept of A. Show that the length of the radius of the circle is 5. So in other words, we must write the circle in the form of A into x minus a squared plus y minus b squared is equal to r squared. That's what we need to write it in that way. So taking the equation into account, so it's x squared minus 6x plus a number plus y squared minus 2y plus a number to complete the square root equals 15 plus the first number plus the second number. So what's the number here? It's going to be b times a half, which is 3 squared, which is 9, and 2 times half is 1 squared, which is 1. So that gives us an answer of 25, and here's a perfect square trinomial. Okay, so that's going to be x minus 3 squared plus y minus 1 squared is equal to 25. Therefore, this is the r squared. It's normally this value here, which implies that r is going to be 5. So the radius of the circle is 5. Okay. I'm just going to extract here, because I need to delete, remove this here. So your m value is going to be taken from here as well. So it's going to be 3 and 1. Alright. I just need to take this off here. So the next question says determine the coordinates of A. So what is A? A is your y-intercept. How do you calculate y-intercept? At x equal to 0. So 0 squared minus 6 times 0 plus y squared minus 2y equals 15. So we drop that. So y squared minus 2y minus 15 is equal to 0. Trinomial, you can use a quadratic formula. So it's 5 and 3 minus plus, so y is equal to 5 or y is equal to minus 3. Why do we have two values? Why do we have two values? Because there are 2 points of intersection on this graph. Okay, so this one being minus 3. So your A's coordinate is then with a positive one. Why? Because it's a positive part of your y-axis. So it's 0 and 5. Okay. The next question says write down the coordinates of M that we know already. The coordinates of M is going to be 3 and 1. Okay. Next question, hence write down the coordinates of B. And the coordinates of B is on the other end of the line. So what we have here is the case, we have the midpoint. We know M is the midpoint, which is 3 and 1. And then A, which is 0 and 5. And B lies here. Let's call that for now x and 1. So we know that x plus 0 over 2 is equal to 3. Or y plus 5 over 2 is equal to 1. So we cross multiply. So 0 plus x is x is equal to 6. Or cross multiply here, so y plus 5 is equal to 2, y is minus 3. So therefore the coordinates of B is going to be 6 and negative 3. Okay. So that's 6 and negative 3. Again, taking this off here. Determine the equation of the tangent to the circle at B. That's your next question. Determine the equation of the tangent of the circle at B. So if you draw a tangent here, we know that the tangent will be 90 degrees to your radius, your diameter. Okay? The equation of the tangent will be in the form of y is equal to mx plus c. To calculate the gradient, I'm going to work out the gradient of AB first. Gradient of AB is going to be y2 minus y1 over x2 minus x1. So it's going to be negative 3 minus 5 over 6 minus 0, which is negative 4 over 3. It's negative 8 over 3. So the gradient of the tangent at B is going to be 3 over 4. Why? So the gradient of the tangent times the gradient of the radii of the radius is minus 1. Okay? So negative 1 divided by negative 4 over 3 gives you 3 over 4. The equation of this graph is y is equal to 3 over 4x plus c. We need to substitute b, which is 6 and minus 3. So that's negative 3 is equal to 3 over 4 times 6 plus c, which implies that c is equal to, so you put in your calculator, negative 3 minus 3 over 4 times 6. Okay, it's negative 15 over 2. Negative 15 over 2. Which now implies that, which now states that y is equal to 3 over 4x minus 15 over 2 is the equation of the tangent at the point B. Okay. Let's carry on. Question 3.2. 3.2 we are told. Question 3.2 we are told the lines with the equation 3y plus 4x plus 1 is equal to 0 and x plus y plus 1 is equal to 0 are diameters of a circle with center C. So you've got the circle, we have two diameters, there's your center C, one being 3y plus 4x plus 1 equals 0, and the other one is x plus y plus 1 is equal to 0. Okay, so you remember if that is the equations of the diameters, okay, so then the line is not necessarily going all the way out, but of course then that would be your diameter as indicated there. Okay, so that mustn't be, whoops. You guys get the idea? Okay, that shouldn't be. Alright, so the center C is also the point of intersection of the two graphs, of the two diameters. Determine the equation of the circle if it passes through the origin. So the circle is also going through the origin, so that could be a point on the circle as well. So that's the scenario you have there. The coordinates of the origin is 0 and 0, of course. So we need to know the equation of the circle with the center not at the origin will follow the form x minus a squared plus y minus b squared is equal to r squared. Okay. So to calculate the center of the circle, I need to calculate C, which is the point of intersection. So for the first equation, x plus y plus 1 is equal to 0. So x is equal to minus y minus 1. This is equation 1. You substitute equation 1 into equation 2, which is 3y plus 4x plus 1. So you'll have 3y plus 4 times minus y minus 1 plus 1. So that would give you 3y minus 4y minus 4 plus 1 is equal to 0. So that is y is equal to 3. Now we calculate x, we substitute that back into equation 1. So x is equal to minus 3 minus 1, which is negative 4. So the coordinates of C, which is the center of the circle, is 3 and negative 4. Okay, so we say x minus 3 squared plus y plus 4 squared is equal to r squared. Now in pursuit of calculating r, I'm going to substitute your origin, which is 0 and 0, as the point on this graph, remembering that's a x and a y. So 0 minus 3 squared plus 0 plus 4 squared is equal to r squared, which is 9 plus 16 is 25. So therefore the equation of the circle is x minus 3 squared plus 1 plus 4 squared is equal to 25. Okay. Have I made a mistake? Okay, I'm going to pause the video at this point. Yes, I have made a mistake. My mistake is here. Okay, so that is going to be negative y is equal to, that is negative 3. No? Take it over, becomes positive 3. So therefore, y is equal to minus 3. Okay, which then makes this incorrect. So y is minus 3. It's going to be minus 3 minus 1, which is 2. Okay, so the C coordinate is actually positive 2 and minus 3. Okay, alright. So the equation is going to be x minus 2 squared plus y plus 3 squared is equal to r squared. We'll substitute 0 and 0 because that's going through the circle, going through the origin. That's an x and a y. 0 minus 2 squared plus y plus 3 squared is equal to r squared. And then it all comes back, okay? So that's going to give you 4 squared. 2 squared is 4. This is going to be 0 here. So it's 9 is 13. R squared is equal to 13. So the equation of this circle is x minus 2 squared plus y plus 3 squared is equal to 13. Okay, that should be correct now. Sorry about that once again. Let's carry on. Question 4. In question 4 we are told that if cos of theta is equal to t, and theta is less than 90, which means to say lying in the first quadrant, I didn't have to even draw it in this quadrant, so that is theta, cos is adjacent over hypotenuse. So adjacent is the root t, hypotenuse is 1. So I must calculate my opposite. So opposite squared is equal to hypotenuse squared minus the other side squared. So it's a t. So it's 1 minus t. So your opposite is going to be the square root there. It has to be positive because that's on the positive part of your y-axis. So the question says tan of theta. So tan of theta is going to be your opposite, which is the root of 1 minus t over the adjacent, which is root t. Okay. Then the next question says, what's a different sound there? Put this up here. Put that down. The next question was to calculate cos of theta minus 30. So we need to first do the cos expansion, which is cos alpha cos beta plus sine alpha sine beta, where your alpha angle is theta and your beta angle of course is 30. That belongs to the special triangle of 31 to root 3 there, and of course 60 lines there. So cos of theta is adjacent of hypotenuse, so it's a root t over 1 times cos of 30 is a root 3 over 2 plus sine of theta is opposite over hypotenuse times sine of 30 is. So it has 1 common denominator there. So that's going to give you 3t, the root thereof, plus the root of 1 minus t. Okay, or you could have written as root 3 root t plus the root 1 minus t over 2. Okay, which is basically the same thing. Okay. And then the next question, you're asked to work out cos of 2 theta. So cos 2 theta, cos can be written as 1 of 3. Okay, so I'm just going to use the first one. So it's 2 cos squared theta minus 1. So cos of theta we know is going to give you a root of t. So it's 2 times the root of t squared minus 1, which is simply equal to 2t minus 1. Okay. Okay, the next one. 4.2. In question 4.2 we are asked to prove the following identity. So of course left and right hand side story here. So left hand side is equal to, I'm going to expand that, so it's going to be 2 sine x cos x times cos x over 90 minus, that takes to the first quadrant, cos is positive, what changes to sine, so it's 2 sine x plus tan can be written of course as sine over cos, sine x over cos x, 180 plus, that takes us to the third quadrant, cos is negative, change that to a negative, cos of x times, if I add 360 twice, that falls away. If I add for the third time, I'll add 360 minus x, which takes you to the third quadrant. Sign is negative in that quadrant, which results in a positive there. Positive sign x. Okay. So from here, it's a bit of tidying up to do. That cancels. So I'm left with cos squared x plus that cancels. Sin x times sin x is sin squared x. And sin x plus cos sin squared x plus cos squared x is of course 1, which is equal to the right hand side. Okay. Quite a bit of marks that could be attained in this question. In question 4.3, it says find the general solution. Again, we need to first change this and that. Okay, so tan can be written as sin a over cos a is equal to 2 over 3. Sine can be written as 2 sin a cos a. Okay, so cross multiplier. So that's going to give you sin a and equals 4. Okay, cross multiply. I'm going to get rid of the 3 as well one time. Otherwise, I'm going to work with a fraction, which I don't want to do. So it's going to be 4 sin a cos squared a. Alright, take everything to one side because it's quadratic here. So it's sin a cos squared a minus 3 sin a. As you can see here, a sin a is a common factor. I'm left with 4 cos squared a minus 3. Alright. So from here we can say that sin of a is equal to 0 or cos squared a is equal to 3 over. So I'm going to go with the first one where sin of a is equal to 0. Let's pull this down here. Where sin of a is equal to 0, you take it to the graph. That's your sine graph here. So it's 0 at 0, 180 and 360. So a is equal to, that happens every 180 degrees. Okay? So I could have written 0 plus k times 360 or 180 plus k times 360. Or I can write it as 1, which is 0 plus k times 180. Okay? On the other hand, cos squared of a is equal to 3 over 4, the square root thereof, don't forget plus minus, so it's a root 3 over. So this tells us that cos is positive and it's negative. Okay. Okay, so this says that cos is positive and negative, which means to say it is in all 4 quadrants. Alright. It's in all 4 quadrants. So if cos is positive, it lies in quadrant 1 and 4. So my reference angle A is going to be r cos of the root 3 over 2, which takes to the special angle, which is 60 degrees. Okay. So that one is going to be A is equal to plus minus 60 degrees plus k times 360. Or you could have written it as A is equal to 60 plus k times 360, or A is equal to 360 minus 60, which is 300 degrees plus k times 360. Or it is in quadrant 2 and 3. In that quadrant it's going to be 180 minus, that's going to be plus minus 120 plus k times 360, where k is an element of integers. Otherwise, instead of writing it like that, we could have said x is equal to 360 minus 60, which is 120 plus k times 360, or a is equal to 180 plus 60, which is 240 plus k times 360. You get the full mark either way. Okay. Bye. So that brings us to question 5. At this point, I'm going to pause the video quickly. There's a correction here. I said the reference angle is 60. It's actually 30. If cos of a is equal to half, then you would have been 60. So which means to say that would simply be plus minus 30 degrees or plus minus 150 degrees. Okay. Or this whole thing here could have been written if I divide this by this solution actually happens every 60 degrees. So this could have been written as A is equal to plus minus 30 plus K times 180. Where K is an element of integers. This is another way of writing the same thing. Okay. So sorry about that again. Okay, so at this point, we're looking at question 5. We're told that the diagram below shows the boundaries of a field A, B, C, E, D. AD is parallel to BC and AB is perpendicular to BC. Then we are told that BAC is equal to DCE, which is equal to X, and ACD is Y. DE is K. So all of that information is, of course, on this diagram. Okay. Just doing that so I can enlarge this diagram a bit. So the question says, show that ADC, which is this angle here, is going to be 90 minus y minus x. Okay, giving the reasons. So, in other words, I need to know this angle on the side of that angle. Okay, so what I'm going to do is I'm going to go with co-interior angles. So, angle A1 is equal to 180 minus 90 minus x. Why? That is co-interior angles. Don't forget to say that AD is parallel to BC. So A1 is equal to 90 minus x. Okay. 90 minus x. So now we can say that ADC is equal to 180 minus y minus 90 minus x. Why? So this is sum of triangles. It's triangle ADC. Okay. So ADC is going to be 180 minus 90 is 90 minus y plus x. As you see, they wanted the y and the x in the bracket. Take out negative as a common factor. And then they have what they are looking for, which is of course 90 minus x minus y. Now y minus x, other way around. Okay. So that's that. Let's look at 5.2. Question 5.2 says determine and find DC in terms of x. So DC is length. So we have a triangle looking like that. X and K. So there's your x, that's your 90, that's your D, and that's your K. So I must use opposite. And I must use DC, which is your adjacent. So of course it's tan. So tan of x is equal to K over DC. So DC cross multiply. And then, so I'll have DC tan x equal to K. Divide by tan x both sides. So DC is equal to K over tan x. Okay. Next one. It says, hence prove that. So with the information that we've calculated thus far, we must prove that 5.3 AC, which is this date here, and AC can be written as K cos y minus x over sin x. As you can see in that triangle, we have many angles. So definitely we're going to use the sine one. Okay. So you must work out AC. So AC over sine of ADC equal to DC over sine 90 minus x. Okay. Or sine, sorry, not, I'm trying to write it in terms of the letters here. So it's DAC, the naming of the letters. So AC E over sine 90 minus y minus x is equal to DC, which is k over tan x over sine DAC, which is 90 minus x. Okay. So we'll take it up there. So AC is equal to k over tan x. Okay. That will go up, so it belongs to the numerator. Sine 90 minus, that takes to the first quadrant. Sine is positive, but changes to cos y minus x over tan, sine 90 minus x gives you cos x. First quadrant, sine is positive. Right. Now, that is not what we are here at the bottom. However, tan can be written as sine of the cos. So it's k cos y minus x over sine x over cos x times cos x over 4. Of course, that cancels. Leave you with k cos y minus x over sine x. And they have just proven what they wanted us to prove. Okay. I'll take a calculator away so that you can see anything that you missed in. Alright. So that takes us to question 6. Geometry. Okay, so in question 6 we are told, okay, that in the diagram alongside, let's make it a bit smaller, in the diagram alongside, x, y, t is a triangle with Q as the midpoint. X, y, t. X, y, triangle where Q is the midpoint of y, t. So then that means to say that that is equal to that there. Q is the midpoint of y, yes. P is the point on x, y such that Q, X and P intersect at S. Then we are told that R, S is parallel to X, Y, R with R on Y, T. Yeah, Y, R on Y, T. Then we are told that XS over XQ is equal to 1 over 3. XS. So if this is K, then X is an XQ is the whole length. It's going to be 3K, so that's going to be 2K. Okay, from there to there. Okay, and of course our length is 3. Determine, give me the reasons, the numerical value of YR. So YR, let's use the other color. YR over RQ. So YR over RQ is the same as XS over SQ. So that is going to be equal to YR SX over SQ. Why? Because of the proportionality theorem. Okay? Which simply gives us K over 2K, which is 1 meter. Okay, so that simply would be, if this is of course an A, this will be 2A. And of course this whole length will be 3A now, because Q is the solid point. Okay? Why do I put A and K there? Because These are ratios. Okay. Let's pull this up here. The question says determine the numerical value of TS. Let's use the other color here. TS over TP. So remember, it's lying between these parallels. Okay? So TS over TP is to be equal to TS over TP is equal to TR over T1. Why? Because of the proportionality theorem, with SR being parallel to H1. Okay. So, proportionality theorem, with SR being parallel to X1. Alright. So TR of course is going to be 3a plus 2a is 7a over 8a, which is 7 over 8. Okay. Why do I have 7? Supposed to 2 plus 3 is 5. It's around 5a over 6a. It's 5 over 6. Okay. Easy, I make a mistake. You guys don't make mistakes as I do. You guys are much better than me. Alright, so you're still young and you're practicing a lot. Alright, let's look at the next one. So here we are told in question 7. In the diagram below. Okay, we'll pull this up a bit. In the diagram below, PQ is a tangent. So if PQ is a tangent, we know that Q1 is equal to R2. To the circle XRBAT. Then we are told that RT produced, which means to say extended, to be tangent QP at P. TA, where's TA is TA, and RB are produced to meet at S. Then we are told that BA is parallel to SP. Right. So if that's the case, and that angle of course equal to that angle. Then we are told that, right. So let's pull that up. Whatever's written there is on the diagram. So let's pull this up here. So in 7.1, question 7.1, we are told to name with the reasons two other angles equal to x. Name with the reason two other angles is equal to x. So of course A1 is x. Why? That's alternate angles with BA being parallel to SP. Then this is an exterior angle of a cyclic quad. There's your cyclic quad. One of the ends is extended, so it has to be equal to B1 as well. Oh, sorry, R1. R1 is not B1, R1. So R1 is equal to X. Why? Because that's an exterior angle of cyclic. Okay. So these are 4 marks. Next question, 7.2. 7.2, you are asked to prove that triangle PTS is similar to triangle PSR. So for that, we know that angle P2 is going to be a common angle. Okay? And then we can see that this angle there is equal to that angle. Okay? Why? Because both is x. So the third angle will fall into place as it is, the third angle of a triangle. Alright, so let's lay that out. So 7.2, we say in triangle PTS and triangle PSO. Okay, in the link below you will find a link that will take you through to this question paper with this memo. Okay? You'll find it in the description box. So what do we say? We can say that angle P2, of course, is your common angle. Sorry about that. One of the cross alarms has been off. Then angle TSP is equal to angle R1, which is equal to x. Where did we get that? That was proven. Then T2 is equal to RSP, which is the third angle of triangle. So therefore, PTS, triangle PTS, is similar to triangle PSR. Why? Because of angle. Okay. So this angle here is equal to the dollar. Okay. So let's look at the next question. The next question we are asked to prove that. So the assignment is going to write down here somewhere. We'll probably use this soon. Go with 7.3. 7.3, again you must prove. So we say in triangle 7.3 is in triangle PQT and triangle PRQ. You don't start off by saying the triangles are similar. Okay, to prove that or show that question. So you can't do what that is indicated now. So PQT. PQT and PRQ. We know that's a common angle. We know that that angle is equal to that angle tangible theorem. And the third angle will be equal because of the third angle of a triangle. Okay. So we're saying in triangle PQT and triangle PRQ, we're going to say that angle P1 is a common angle. Okay. Then Q1 is equal to R2. Why? Because that's of the tangible theorem. Alright. Then T1, angle T1 is equal to, angle T1 is equal to RQP. Okay, why? That's the third angle of triangle. So therefore, triangle PQT is similar to triangle PRQ. Why? Angle. Okay. I'm sure we're going to use that as well. That's 7.3a. Let's look at the B part of the question. Alright. So it says show that PQ squared, so PQ is in this triangle here. I've used the red. Let's go purple. Okay. That is that length. And as you can see, here's the PQ. I'll pick it up twice there. So yes, I'm going to go with 7.38. So, of course, that's your ratio question. So it's PQ, and this is question PQ over PR equals QT over RQ equals PT over PP. And where is this coming from? The fact that sides are in proportion. Or we can say, use that, as your reason. Okay. Either one will get you the full mark there. Alright. So they got PQ squared, so I'll pick it up that way. So PQ squared is equal to PT times PR. And that is what they want to do. So that is in order. And then the next question says, hence prove that we're required to prove now that PQ is equal to PS. So PQ, we already got what PQ squared is. Okay? So if I look here, I'm seeing a PS and here's a PS. Okay, so I'm going to go with the ratios on that side and let's see what's going to happen. Okay? So this is 7.4. So it's going to be PT over PS is equal to TS over SR equals PS over PR. Where is this coming from? Triangle PTS is similar to triangle PSR. Okay. So PS squared is going to come from there. So PS squared is equal to PT times PR. But what we notice is that PT times PR, PT times PR. Can you see the link there? So which means to say if that is the case, therefore PQ squared has to be equal to PS squared. So therefore PQ is equal to PS. Okay. Let's go to the next question. This is a bonus question. Yes. Here the bonus question says that given m is equal to 1 over x squared plus 5x plus 7, the maximum value of m is. So the maximum value of this fraction will occur at its maximum value, at the denominator's maximum value. Okay? No, at the denominator's minimum value. So why? Because why? This is the reciprocal function. Okay? So how do we calculate the maximum value? Since it's quadratic, you can either complete the square or you can apply your derivative. But at this point we didn't do the derivative, the application of derivatives yet. Okay? So what I'm going to do is, because with this group I haven't covered the application of derivatives in this question, so I'm just going to go with finding the turning point. Okay? Again, the maximum will occur at the minimum denominator. Remember that is 1 over the minimum, which will give you the maximum. It's a reciprocal function. Okay? So you can find the turning point. We're going to complete the square. And just complete the square. So that's going to give you x squared plus 5x plus a number minus the same number plus 7. So that's going to give you x squared. So the number that gets added here is 5 over 2. So that's b times r squared, which is 25 over 4. So in the completing of the square form, with the turning point form, that will give you 28 is negative 3 over 4. So the turning point here, hi boss, how's it? Good, good. Alright, so just hang on. I'm going to pause the video at this point. Okay, sorry about that. So, just getting back to this here. So it's minus 5. So it's 28 is going to be positive 3 over 4. Yeah? So the minimum value of this is actually 3 over 4. The minimum value of the denominator. So m has to be equal to 1 over that, which is 4 over 3, which makes the answer C. Okay. And then the last question says, hence, that means to substitute my previous answer, which I've selected here. Determine the value of theta. For theta is the element of 0 to 90. If 2 cos of theta equals m, our m value is of course 4 over 3, for which m is a maximum. Okay, so in other words, I must calculate the value of theta. So if 2 cos theta is equal to m, which is 4 over 3, so I divide both sides by 2. So you're going to get 2 over 3. So I go r cos of that. So I go r cos of 2/3. I get then 48 comma 2. Or 48 comma 19. Yeah, 19. Okay. So that's the value for theta for which m will be a maximum. Alright. That basically brings me to the end of this paper. If you have any problems, you can just contact me on the number on the side there. Or if you need the question paper, as I've indicated, the question paper's link will be available in the description below. Okay? Enjoy the holiday.